Picture this. It's 1963, and you're at Riverside International Raceway watching a tiny British roadster with a Ford small block absolutely destroy a field of big block Corvettes and 427 Hemis. The crowd can't believe what they're seeing. This little 289 cubic inch engine, advertised with hydraulic lifters and rated at just 271 horsepower, is making fools of motors nearly twice its size. What nobody in that crowd knew was they were witnessing the birth of an engineering philosophy that would change American racing forever. This is the story of the Ford 289 high-performance V8, an engine that proved once and for all that intelligent engineering beats brute force every single time. And here's the kicker. Ford's marketing department lied about those lifters. They were solid, not hydraulic, and that little deception was just the beginning of what made this engine special. To understand why the 289 Hypo was revolutionary, we need to travel back to the early 1960s. The American automotive world operated on a simple principle. There's no replacement for displacement. Want more power? Build a bigger engine. Chrysler had their 426 Hemi, putting out 425 horsepower. Chevrolet was fielding 427 big blocks with similar numbers. Ford themselves had the 427 side oiler, making north of 400 horses. The recipe was established: big cubes, big power, big weight. But there was a problem brewing. The Sports Car Club of America had just created new racing classes with displacement limits. Trans Am restricted engines to 305 cubic inches. SCCA production classes had similar restrictions. Suddenly, the big block arms race meant nothing. Racing was about to get a lot more sophisticated. Enter Ford's Special Vehicle Operations Team. In late 1962, they received an interesting assignment: create a high-performance version of Ford's existing 289 small block that could compete in these displacement-limited classes. The standard 289 was a workhorse engine, reliable and torquey, producing about 195 horsepower in two-barrel form. But Ford needed something that could run with Chevrolet's fuel-injected 327s and Chrysler's 273 high-performance motors. The engineering team, led by Jim Clark and Tom Hoover, approached the problem methodically. They started with the basic 289 block, which was actually quite robust. The bore was 4.0 inches, stroke was 2.87 inches, giving exactly 289.4 cubic inches of displacement. The block featured 5 main bearings and cross-bolted mains on some versions, providing excellent bottom-end strength, but everything else would need serious attention. First came the heads. Ford engineers completely redesigned the cylinder heads, creating what became known as the C4OE-B casting. These weren't just warmed-over standard heads. The intake ports were enlarged from 1.45 to 1.78 square inches. Exhaust ports grew from 1.25 to 1.45 square inches. The combustion chambers were redesigned with a more efficient shape, reducing volume to 54 cc to bump compression. But here's where it gets interesting. They used screw-in rocker arm studs instead of the standard pressed-in type, allowing for much higher spring pressures without pulling the studs out of the heads. The valve train was where Ford really showed their engineering prowess. Despite what the marketing materials claimed, the 289 Hypo used mechanical solid lifters, not hydraulics. This was crucial for high RPM operation. The camshaft was a work of art. Duration measured 290 degrees on the intake, 290 on the exhaust, with 0.477 inches of lift. The overlap was aggressive for a street engine, giving that characteristic lopey idle that became the Hypo's signature. Valve springs were dual units with an installed pressure of 95 pounds and 240 pounds over the nose. This setup allowed the engine to rev reliably to 6,500 RPM, with many racers pushing past 7,000. The intake manifold was cast iron, not aluminum, like many expected. Ford engineers discovered that the iron manifold's heat retention actually helped fuel atomization, especially important with the carburetor they chose. Speaking of which, The Hypo came with an Autolite 4100 4-barrel carburetor flowing 480 CFM. Not huge by muscle car standards, but perfectly matched to the engine's actual airflow requirements at high RPM. Now let's talk about that compression ratio. At 10.51, the Hypo was pushing the limits of what pump gas could handle in 1963. Ford specified premium fuel only, and they meant it. The pistons were forged aluminum units from TRW, designed to handle the stress of sustained high RPM operation. The connecting rods were shot-peened for strength, and the harmonic balancer was a larger unit borrowed from the 390 big block to handle the increased torsional loads. The exhaust system was equally well thought out. Cast iron headers weren't headers in the traditional sense. They were specially designed exhaust manifolds with improved flow characteristics. They fed into a true dual exhaust system with minimal restriction. Ford engineers spent countless hours on the dyno optimizing pipe diameter and muffler design to minimize back pressure while maintaining acceptable noise levels for street use. But here's what made the 289 Hypo truly special. It was a complete system, not just a collection of hot parts. Every component was designed to work in harmony. The result was an engine that produced its advertised 271 horsepower at 6,000 RPM and 312 lb-ft of torque at 3,400 RPM. Those numbers might not sound impressive today, but remember, this was from 289 cubic inches in 1963. Chevrolet's 327 needed fuel injection to make 360 horsepower, and that engine wasn't even street legal in some states. The first production Hypo engines rolled off the line in June 1963. They were installed in a limited run of 1963 1-2 Fairlanes, creating what many consider the first true muscle car. But it was in the Mustang that the Hypo really found its home. When the Mustang debuted in April 1964, the Hypo was the top engine option, creating the legendary K-code Mustang. At $328 extra, it was expensive, but enthusiasts recognized the value immediately. Now here's where things get really interesting. While Ford was selling Hypo Mustangs to the public, a former Texas chicken farmer turned race car driver was about to make history with this engine. Carroll Shelby had been building his Cobra roadsters with Ford's 260 V8, but he needed more power to compete with the Corvettes dominating SCCA racing. Ford offered him two options, the 427 big block or the 289 Hypo. Most people would have grabbed the 427 without thinking twice. Not Shelby. He understood something fundamental about racing that the big block crowd missed. It's not about power, it's about power-to-weight ratio and balance. The 427 was 200 pounds heavier than the 289 and would have destroyed the Cobra's near-perfect weight distribution. Shelby chose the 289 Hypo, and then he worked his magic. The Shelby-prepared 289s were different animals entirely. Starting with the Hypo as a base, Shelby's team balanced and blueprinted everything. They installed Holley carburetors, some flowing up to 715 CFM on the race versions. Tube headers replaced the cast manifolds. Cam profiles got even more aggressive. Compression ratios climbed to 11.1 or higher. The result? Street Cobras made around 306 horsepower, while full race versions pushed past 350. From 289 cubic inches. The racing results spoke for themselves. In 1964, Shelby Cobras won the SCCA B Production Championship. They did it again in 1965. But the real shock came at tracks like Riverside and Laguna Seca, where 289 Cobras were running down and passing 427 Corvettes on the straights. The press couldn't believe it. How was a 289 outmuscling a 427? The answer lay in the complete package. The 289 Cobra weighed about 2,200 pounds. A 427 Corvette weighed 3,200 pounds. The Cobra's superior power-to-weight ratio meant better acceleration, better braking, and better cornering. But there was more to it. The 289's ability to rev meant it could run shorter gears, keeping the engine in its power band through corners. The big blocks had to run tall gears to avoid over-revving, which put them at a disadvantage coming out of turns. Let me put this in perspective. At the 1964 United States Road Racing Championship at Watkins Glen, Bob Johnson's 289 Cobra set a lap record that stood for 3 years. His fastest lap was nearly 2 seconds quicker than the best 427 Corvette. 2 seconds in road racing is an eternity. The Hypo wasn't just competitive, it was dominant. But Shelby wasn't done with the 289 Hypo. In 1965, Ford asked him to create a special version of the Mustang that could compete in SCCA B production racing. The result was the GT350, and at its heart was a further modified 289 Hypo, making 306 horsepower. The GT350R race version pushed that to 350 horses with improved heads, wilder cams, and individual throttle bodies on some versions. The Trans Am series launched in 1966 with a 305 cubic inch displacement limit. Ford responded by destroking the 289 Hypo to 302 cubic inches, creating the legendary Boss 302. But that's getting ahead of ourselves. In that first Trans Am season, it was modified 289 Hypos doing battle with Chevrolet's Z28s, and the Ford engines more than held their own. What made the Hypo so successful in racing wasn't just power, it was reliability. While big blocks were breaking transmissions and rear axles with their massive torque, the Hypo's power delivery was smooth and manageable. The solid lifter valve train stayed in adjustment longer than hydraulic systems at high RPM. The forged internals could take abuse that would scatter a cast piston big block. Back on the street, the Hypo was developing a reputation. In a 1964 road test, car and driver pushed a Hypo Mustang to 60 mph in 7.6 seconds and through the quarter mile in 15.9 seconds at 89 mph. Those numbers might not impress today, but in 1964, they were supercar territory. More importantly, the Hypo Mustang could corner and stop, something most muscle cars couldn't do. Hot rodders quickly discovered the Hypo's potential. With basic modifications, headers, carburetor, camshaft, street racers were seeing 350 horsepower naturally aspirated. Some pushed further. Mickey Thompson built a supercharged 289 Hypo that made over 500 horsepower. A.K. Miller got similar numbers with turbocharging. The Hypo's strong bottom end and good heads responded well to forced induction, something that wouldn't become mainstream for another 20 years. But here's what's fascinating about the Hypo's development. Ford's engineers knew they were leaving power on the table with the 271 horsepower rating. Internal dynamometer tests showed the engine capable of 290 horsepower with minimal changes. Why did Ford underrate it? Insurance, primarily. But also because Ford understood that reliability sells cars. A 271 horsepower engine that lasted 100,000 miles was better than a 300 horsepower engine that scattered itself at 50,000. Production numbers tell an interesting story. In 1963, only 139 Hypo engines were built, all installed in Fairlanes. In 1964, production jumped to 192 units, mostly in Mustangs. 1965 was the peak year with 3,223 engines produced. 1966 saw 2,008 units, and 1967, the final year, just 11 Hypos were assembled. Total production over 5 years, 7,273 engines. Compare that to the millions of standard 289s Ford built, and you understand why original Hypo cars command such prices today. The Hypo's influence extended far beyond its production run. The engine architecture became the basis for Ford's 302, which would power everything from Trans Am Boss Mustangs to Formula 5000 race cars. The cylinder head design influenced Ford performance engines for the next decade. The philosophy of high-revving, efficient power became Ford's racing calling card. Let's talk about what ownership was actually like. Hypo engines required more maintenance than standard 289s. Those solid lifters needed adjustment every 3,000 miles. The high compression ratio meant premium fuel was mandatory. Put regular in a hypo, and you'd hear detonation that sounded like marbles in a coffee can. Oil changes were critical. The high RPM operation put serious stress on lubricants. Ford recommended 20W50 racing oil, expensive stuff in the 1960s. But owners didn't care about the maintenance. The Hypo had character that no hydraulic cam big block could match. The Lopi idle announced serious intentions. The engine note at 6,000 RPM was a mechanical symphony, and the way power built from 3,500 to 6,500 RPM was addictive. This wasn't the lazy torque of a big block. This was an engine that rewarded skillful driving. The racing success continued throughout the Hypo's life. In 1965, Cobra driver Bob Bondurant won 7 consecutive SCCA races. Ken Miles won the GT class at the 1965 24 Hours of Le Mans in a 289-powered Cobra Daytona Coupe. Jerry Titus dominated Trans Am in a Hypo-powered Mustang. The little engine that Ford's marketing department couldn't even describe accurately was rewriting the rules of American motorsport. There's a technical aspect worth exploring here. The Hypo's connecting rod ratio, the relationship between rod length and stroke, was 1.89.1. This relatively high ratio meant less side loading on the cylinder walls, reducing friction and wear at high RPM. It also meant slower piston acceleration at top dead center, reducing stress on the rods. These subtle engineering details separated the Hypo from crude high-performance engines of the era. The oiling system deserves mention, too. Ford engineers modified the oil passages to ensure adequate lubrication at sustained high RPM. The oil pump was high-volume unit, and the oil pan was baffled to prevent oil starvation during hard cornering. A windage tray reduced parasitic losses from the crankshaft spinning through oil mist. Every detail mattered when you were spinning an engine 2,000 RPM higher than originally designed. But perhaps the Hypo's greatest achievement was philosophical. It proved that American engineers could build sophisticated, high-revving engines that competed on more than just displacement. It showed that efficiency mattered, that power-to-weight ratios trumped absolute power, that engineering elegance could beat brute force. In many ways, the Hypo was the first modern American performance engine. The end came quietly. By 1967, Ford was developing the 302 for Trans Am homologation. The 390 and 428 big blocks were available in Mustangs for customers who wanted tire-smoking torque. The Hypo was caught in the middle, too expensive for casual enthusiasts, not powerful enough for the emerging supercar market. Ford built just 11 Hypo engines in 1967, all for warranty replacement. The production line that had created legends fell silent. But the Hypo's influence lived on. When Ford developed the Boss 302 in 1969, they started with Hypo architecture. The Cleveland heads that powered Ford performance through the 1970s traced their DNA to the Hypo's port design. Even today's Coyote 5.0 shares philosophical roots with the Hypo, high-revving, efficient power from relatively small displacement. Collecting Hypo engines today is serious business. Original K-code Mustangs command 6 figures in perfect condition. Genuine Hypo blocks are identified by casting numbers C30E, C40E, or C50E with a K in the VN position on the block. But buyer beware, more fake Hypos exist than Ford ever built. The heads, intake, and even the harmonic balancer have been reproduced. Authentication requires expertise and often detective work. The restoration community has kept the Hypo alive. Companies like Edelbrock and Ford Racing offer aluminum versions of the Hypo heads. Camshafts matching the original specifications are readily available. You can build a Hypo clone that performs better than the original, though purists will point out it's not the same as Ford's factory engineering. Racing shops still build Hypo-based engines for vintage racing. With modern materials and technology, these engines produce 400 horsepower, naturally aspirated while maintaining the original's character. They're reminders of what Ford's engineers achieved with 1960s technology and slide rules. There's something poetic about the Hypo's story. In an era when everyone else was adding cubic inches, Ford added sophistication. When competitors relied on torque, Ford emphasized horsepower. When the establishment said there's no replacement for displacement, Ford proved them wrong. The 289 Hypo didn't just beat 427 Hemis, it embarrassed them, showed them up as crude anachronisms in a changing world. Think about what the Hypo represented. This was an engine that required driver skill to extract maximum performance. You had to keep the revs up, work the gearbox, maintain momentum. It was the antithesis of the lazy, automatic transmission, straight-line muscle car experience. The Hypo demanded engagement, rewarded precision, punished ham-fisted driving. It was an enthusiast's engine in the truest sense. The legacy extends beyond mere machinery. The Hypo proved that American engineers could think beyond traditional solutions. It demonstrated that racing success came from complete vehicle dynamics, not just engine output. It showed that efficiency and sophistication could coexist with American performance values. In many ways, the Hypo predicted the future of performance cars: lighter, more efficient, technically advanced. Modern Ford performance engineers still reference the Hypo when developing new engines. The philosophy of extracting maximum performance from minimum displacement guides current EcoBoost development. The idea that an engine should be part of a balanced system, not just a power unit, influences every performance Ford. The Hypo's DNA lives on, even if most people don't realize it. So what can we take from the story of the 289 Hypo? Sometimes the best solution isn't the obvious one. Sometimes David really does beat Goliath, not through luck, but through superior engineering. Sometimes a lie about hydraulic lifters launches a legend. The 289 high-performance V8 wasn't just an engine, it was a statement of intent, an engineering philosophy made manifest in iron and aluminum. The next time you see a K-code Mustang at a show or watch vintage racing footage of Cobras destroying big-block Corvettes, remember what you're really seeing. You're witnessing the moment American performance engineering grew up, became sophisticated, proved that brains beat brawn. The 289 Hypo didn't just shock everyone by beating 427 Hemis, it changed what American performance could be. What's your take on the eternal displacement versus efficiency debate? Have you ever experienced the song of a properly tuned Hypo at full chat? Drop your thoughts in the comments below, and don't forget to subscribe for more stories of engineering legends that changed the game.